We talked about this in week 2, and we said that change can be broken into 3 parts. For each person, they have a starting level, which we know is intercept. There's a wrinkle there I'll discuss in a second. Each person has a rate of change, which is the systematic change piece. We know this is a slope. And each person has intra-individual variability, the extent to which their slope line doesn't quite capture the performance at each occasion. These are the departures from smoothness that you see in the figure, the squiggles. So in this case, the intercept represents each person's value of y at time 0, which here is sometime in the middle of a time span. The intercept of 0 will be located at different points depending on your study. Often it'll be on the left margin when your lowest value of x time is 0. These differences in level are between person differences. Next, you can see from the first to the last occasion that there are individual differences in slope. Some people improve much faster than others. The lines are all going in slightly different directions, even as the more general trend for everyone is lower left to upper right. This is what we've been calling systematic change or slope. Finally, you can see that the lines are clearly linear but not perfectly smooth. The squiggly departures from a smooth line show us intra-individual variability. Those occasions where participants performed a little higher or lower than expected, probably because concurrently something good or bad was happening to them that was reflected in their scores at that occasion. So now let's apply those concepts to simple two-occasion cross-legs. Why might violent TV and aggression be correlated over time? One, because some people watch more TV than others, and that is stable over time. Two, because some people are more aggressive over time, and that is stable over time. Or specifically, between these pairs of occasions, because I increased my violent TV watching between time 1 and time 2. And that would predict more aggression at time 3, or the reverse. And so far, we haven't separated those two sources of variance. So we want to separate stable between person level differences from change. And we know how to do that. So I put up this path diagram from earlier this week to remind us that we separate level from change all the time. We do it by pulling out stable between person differences in an intercept, that vector of ones, and change in a slope. The take home here is that an intercept factor is a way to pull out or separate stable between person differences. And we just said that a problem with CLPM is that we usually fail to pull out stable between person differences. So the answer is pull out an intercept. Let's forge ahead. The solution to the problem of confounded between and within person variance in CLPM has been to create RICLPM, the Random Intercept Cross-Lag Panel Model. This will permit us to separate the part of the relationship that is due to stable between person differences from the part of the relationship that reflects coupled change. So starting with the same variables, we first pull out intercepts for both of those variables, that vector of ones, representing stable between person differences in x and y. After pulling out the intercept variance, the residuals in each x and y represent the same as they do in MLM or SEM growth models, residual change. And between these residuals, we pull out the autoregressions for the same reason as before, so that any cross-lags are unique, controlling for any pre-existing variance and any concurrent relationships. So after the intercept and the autoregressions, we specify our cross-lags. And then on top of intercept factors, autoregressions, and cross-lags, we also estimate the correlation between intercepts. This will tell us how much stable between person differences in x and y are associated. And implied after intercept factors, autoregressions, cross-lags, and correlated individual differences, we will estimate the residual for each occasion. Why? Because remember that after estimating intercept factors, autoregressions, cross-lags, correlated individual differences, residuals, we use those residuals to estimate all possible concurrent relationships so that we can truly separate cross-lagged relationships over time from any concurrent relationships. Let's set this up in Lavaan. The first big thing, we estimate x and y intercept factors on lines 7 and 8. We also convert the leftover variance in x and y into singly indicated factors, one per measured variable. Why? That's just a trick so that we can estimate residuals coming up. Lines 3 through 6 estimate the autoregressions and cross-lags, same as in the last model, except this time we're estimating these not between the original measured variables, but on the residualized variables after the intercepts, the stable between person differences, have been partialed out. Lines 9 and 12 through 15 estimate the concurrent relationships between each pair of x and y, and lines 18 through 20 are new for us. They estimate the variance and covariance of our intercept factors, our stable between person differences. And finally, lines 1 through 11 estimate the residual variance of the within person-centered variables at each occasion. The fit is great, even though we haven't really been paying attention to it. More on that in a second. As always in growth models, here are our intercept factors fully fixed. And here are those intercept removed residual x's and y's that we'll actually do the cross-lags with. Nothing substantive here. And now we get to the regressions. And compared to the CLPM, the RI-CLPM tends to have smaller cross-lags. The term used is attenuated, because now this is a smaller slice of variance with the stable between person differences removed. And in fact, now we're in a situation where only the path from x to y ever reaches significance, and the path from y to x never reaches significance. More than ever, this makes us feel like x is the leading indicator and y is the lagging indicator. Again, we have the caveat that we aren't directly comparing those two cross-lags to one another, so we haven't done the test to say that the path from x to y is significantly larger than the path from y to x. But overall, it's striking that the conclusion you might draw from the RI-CLPM is similar to what we got with the CLPM, that x is a leading indicator. But why did this happen? Because, as you see here at bottom, the stable between person differences in x and y were not significantly related. So when we pulled that out, we didn't really affect what went into the cross-lag much. That's unique to this data example. In other data examples, including one I'll show you shortly, it might make a bigger difference. I'll skip over these next two slides because, again, they don't add anything to our interpretation of cross-lags, intercepts, variances, except to make sure none are negative. By the color coding I had to do, you get the sense that there's a lot to look at. We get a lot of numbers. It's hard to take away a generalizable conclusion of chicken and egg or anything else. One possible solution would be to add some equality constraints to lead to a more global set of estimates that treat all pairs of occasions as replications of the same process that can be averaged.